Hi, my name is Hannah Miller, and I work at Iway High School, which is a part of Calcasieu Parish School Board. In this video that you're about to see, I'm teaching a room full of lovely freshmen, and today the goal of the lesson is to cover two Algebra 1 standards. The first one is to rewrite expressions involving radicals and rational exponents, and the second is to use the structure of an expression to identify ways to rewrite it. The curriculum that I use in my Math Essentials class is the Springboard curriculum provided by my district. Students are expected to do two things by the end of the lesson. The first is to write and simplify radical expressions, and the second is to understand what is meant by a rational exponent. Prior to this lesson, I prepared to teach by sitting down with the Teacher Edition Springboard textbook and transferring practice problems from the book to a worksheet I created using Canva. The review worksheet is curriculum aligned and standards based, so the students get additional practice in a very accessible way while maintaining the same Springboard rigor that's in their textbook. Now, my Math Essentials class objective is to serve as an extra hour of support and remediation for students who scored below a basic on their 8th grade math leap. So what this looks like is, for my first 2 hours that I teach in the morning, I'm teaching Math Essentials. And then these same students return to me in the afternoon again for Algebra 1. Because of this system, my class is structured in an intervention, instruction, remediation type style. So before students learn 20.1 radical expressions in the Algebra 1 Springboard textbook, we reviewed exponent rules and practiced problems to improve fluency with perfect squares to make the Algebra 1 lessons more accessible. This was part of the intervention in the cycle that we do in Math Essentials. Then the instruction cycle was incorporated in Algebra 1. The students actually learned how to simplify radicals and rewrite rational exponents. So today's lesson falls underneath the remediation part of the cycle. I wanted my students to have extra practice simplifying radical expressions to hopefully improve their success in performing operations with radical expressions in their future Algebra 1 lessons. In order for my students to successfully add, subtract, multiply, or divide radical expressions, they've got to demonstrate mastery in simplifying radical expressions. If a student can break down a non-perfect square using the prime factorization method that I taught them, they can successfully simplify any radical expression, whether they're adding it, subtracting it, multiplying it, or dividing it. So what I want you to know about my students before you watch this video is that every student who sits in my class, who takes my Math Essentials class, scored below a basic on their 8th grade LEAP class. But as freshmen, they get to come see me twice a day for a total of 100 minutes of math instruction, with the hopes of growth towards mastery. Because my students have not met their learning objectives in previous years, I purposefully and intentionally craft my Math Essentials assignments to scaffold problems, provide support through success criteria, which we refer to as steps to success in my class, and incorporate other strategies like mnemonics or repetition or hand signals to support student growth. It is my goal for my students to leave Math Essentials ready to conquer their Algebra 1 lesson for the day, and to leave Algebra 1 feeling confident in their abilities and successful in their endeavors. I'm excited to see how they're going to do today. Going over the bell ringer. If she gets it all right, I'll give her $1 and everyone at her group $1. Riera and Keelan did not look excited enough for this deal. Square root of 16 is 4. Good job. Square root of 25 is 5. Good job. 6, 7,
It goes in order.
8, 9. It does go in order. Will it always go in order every time you see it?
Or no?
No.
Or maybe like,
Then we're going to understand what is meant by a rational exponent. All right, so you've seen this before, but I don't know if you know what it was called. If I have a base and it's raised to the exponent that's a fraction, that's a rational exponent. All right? So, what is a radical expression? We have learned this. We've practiced it in Algebra 1, and now we're relearning it, all right? So if I point at this little number, can someone raise their hand and tell me what this little number is? Bria? Cubed. Cubed, very good. Now I'm looking for something else, another word to define it. Starts with an I. Madison?
Index.
Index, good job. I want everyone to say index. You gonna say it? Index. Index is telling me, is it an exponent? No. Like Brielle said, that was telling me, I need to sign this. It was telling me it's cubed, right? So if I simplify it, this means that I'm looking for groups of how many? Three. Good. Now, can someone raise their hand and tell me what the number under the house is called? Mike? Close. I'm going to give them money for trying. Brayden, what you got? Nope. Liera? Nope. Madison? Radican. Now listen. Brayden is right. When I have 6 to the 3rd power, that's called the base. Now, if I'm looking for the cube root of 6, I want to find the root of 6, right? So all of your answers were correct, but I was looking for that specific word. Can y'all all say radican? Radican. So this is the index. This is the what? Index. And what else is prime? Now I want you to break down your b's. Draw your little arrow. If it's b to the 3rd power, how many b's are there going to be? So I do b times b times b. Now I'm looking for pairs. Let's look in our numbers first. Do I have a pair? So circle it. Okay, now I'm looking at my b's. Do I have a pair? Yeah, so circle it. So my pairs, how many b's did you just circle? So my pairs of 3s, they get married, and the 2 3s become how many 3s? 2 3s become 1. Yep. So I'm gonna put a 3 outside the house. Now, I can't draw my house just yet because I got a pair of b's. So those 2 b's become how many b's? 1. So I've got 3 b. And in the house, who do I have left? And who else is left? Is there another 5? No. When that timer goes up, we'll go over it on the board.
Right. So we do it. We divide these two, right?
Mm-hmm. Now I have a pair of my bees. Let us move on. That is your check for understanding. Walking around, I saw everyone got A right. Give yourself a pat on the back. Most of you got B right. Let's look at B before we move on. I've got the cube root of 81x to the 7th. If I have x to the 7th, how many x's do I have? 7. On your paper, I saw a lot of you guys break that x down. Y'all know how to do that. That part y'all got. Now, how can I break 81? What's the smallest prime number that goes in 81?
No, 3.
3 and 9.
3 and 27. It's 3 and 27.
You could do 9 and 9 and then break. Let's do Brielle's method.
I did it.
Don't do Brielle's method?
Don't do my method. No, don't do her.
I did the same thing.
You did the same thing? I just want to show y'all how it can work. So Brielle says 9 and 9. Then I can break 9 up into 3. And then I can break 9 up into 3 and 3. And then you're done. So it doesn't look like the typical tree that our work looks like, but does it still work? Yes. As long as you break every factor up into your prime factor, as we learn this and work on this, I don't want y'all to get so caught up in just thinking about factors that it takes up your whole time and you can't actually simplify it. Does that make sense? That's why I tell y'all the smallest factor. Because usually the smallest factor is going to be 2 or 3. Yeah. So do I have any groups of, or no? Y'all tell me, am I looking for pairs or groups of 3?
Groups of 3.
Do I have any?
Yes.
Do I have any groups of 3 in my x's?
Yes.
How many?
2.
I've got 2 groups of 3 in my x's.
2x. Or x squared.
X squared. So outside I'm going to have 3x to the 2nd power. And the cube root of what's left in the house?
3x.
3x. I would say a lot of you guys got 3x and the cube root of 3x. Y'all left out that x squared. If you're taking out 2 groups of x's, let's review what we've already know how to do with exponent rules. If I have x times x, when I'm multiplying bases, what do I do with exponents? I add them. What's the understood exponent on x? 1. What's the understood exponent on this x? 1. What's 1? plus 1?
2.
That's how I got x squared, okay? So if you can't see that from just getting two groups of x's, you can do the whole work. Now we're moving on to the next page. This is the lesson, the part of the lesson that I think you guys really like. This is rewriting expressions with rational exponents as radical expressions. So when I say rational exponent, that's an exponent that's a fraction, okay? So, first step is to draw your radical symbol and write your radicand. All right, so that's your big number in the house. That's what that means, right? Then the numerator, what letter does numerator start with? The numerator goes on the
Inside.
inside. The numerator goes on the, I want y'all to say that. The numerator goes on the
Inside.
So I want y'all to fill in that little blank. Numerator goes on the inside. What letter does inside have in it? I mean, oh yeah, it has in. Or you can say in. It has the literal word in there, right? What letter does numerator start with? In. The numerator goes on the
Inside.
Good. So if the numerator is on the inside, then the denominator is going to go on the outside. So I'm going to fill in that word. I wanted y'all to write this because writing stuff down helps you get better into your heads. Numerator goes on the denominator goes on the. So let's look at this. For each expression with a fraction exponent, write an equivalent expression with the radical. My first step is to draw my radical symbol and write your radicand. So I'm just going to put my radical symbol. Now what is my radicand? What's my big number there?
16.
16. So we're going to stop there for just a second. Just look at it. Look how beautiful it is, the square root of 16. Now what is my numerator of that exponent? What's the numerator?
1.
So 1 goes on the
Inside.
inside. 1 goes on the inside because my numerator goes on the
Outside. Oh, inside. They said denominator.
Now my denominator, what is my denominator? So how would I read this?
16.
What is this? If it has a 2, what'd you say?
Index.
Square root. That's my index. 2 is my index. So this is my square root. Do I have to put a 2 on a square root? No. So could I just rewrite this as square root? Now my exponent is 1. What does every number have an understood exponent of? 1. So do I have to write the 1 there? No. So that's just the square root of 16. If you put this on a test, am I going to mark you wrong?
You will not.
No, I would not. Because technically
You're right.
you're right. Now, we're going to do 2 together, and then I want y'all to try 3 and 4 on your own. So number 2, first thing I want you to do, draw the radical symbol. Then I want you to put your radicand in there. What's the big number there? 7. Now I want you to look at your numerator and your denominator. Numerator, what?
Inside.
Yes. What letter does numerator start with?
In.
What word does inside have in it?
In.
So my numerator goes on the,
Inside.
Leah already told me that is. Now what's going to go on the outside?
5.
5. So how would I read this? Does anyone have an idea? I want y'all in your groups to just try. Don't tell me. You can whisper. Do y'all have any idea in your groups? No, do y'all have any idea? No? Okay, I read this as the 5th root. Everyone say the 5th root of 7 to the 4th power. So that one's kind of long, right? You know, it's not the square root, it's not the cube root, it's the 5th root. All right? I want y'all to try 3 and 4 on your own. I'm only going to give y'all 2 minutes to try that on your own. Oh, and look at here. Guess what this group has?
1 wrong.
No.
All of them
Why would you doubt them?
Why would
They
you
got
doubt
them
them?
all
That is-
right. All right, y'all. Hands in the middle.
Bruh.
You ready? La rumba on me. La rumba on 3. 1, 2, 3. La rumba.
Oh,
Now, here's what I want y'all to do. Check for understanding. This one you're working backwards and you've never seen this before. So we're going to work A out together. Then I want you to try B on your own. You don't have to get B right. I just want to see what you think, okay? working A out together. I know that my numerator goes on the inside. Well, now I'm working backwards, so my inside's gonna go on the
Outside. No, yeah, it go outside.
my numerator goes on the inside. So if I'm making it back into a fraction, my inside's gonna be my
Outside, denominator.
What are you saying?
hold on, let's get this straight.
It's gonna become your denominator, right?
My numerator I get from my inside.
Yeah,
My denominator I get from my
outside.
outside.
What we just.
That's what you're saying? Oh.
Yes.
Oh, sorry. So I'm gonna write my big base 15. Then I want to raise it to a fraction, right? My numerator is coming from the inside. So what exponent is 15 raised to? 1.
1 over 2.
1 over 3. So y'all try B on your own. I'm only gonna give y'all 39 seconds.
18.
What? 18 of 1 over
2
1.
and 1.
Alright.
Oh, this one.
1 over 2, because the 18
Wait, I clocked
is
out.
1.
Then you got the
But you
2
got right.
from right here,
Yes,
because
indeed.
it's all about.
Y'all have 2 minutes of class left. I want you to circle. Do y'all feel happy? Do you feel less glad? You feel mid? You feel worse than mid? You feel bad? Or you feel hatred? Circle the face that represents how you feel about this lesson. This is your self-assessment. Circle the face. Turn it in. Now that my lesson is taught, I'd like to share with you about the outcomes of the lesson. So my lesson objectives were for students to write and simplify radical expressions and to understand what is meant by a rational exponent. These objectives were successfully met. After reviewing student work, I know that 100% of my students successfully completed their review worksheet. Both objectives were measured by the Check for Understanding questions on the worksheet, which my students completed successfully. My exit ticket also served to help reveal how students feel about this lesson. I asked students to rate their understanding on a scale of 1 to 5 and circle the face that best describes their feelings about the lessons. So the scale looks a little bit like this, and I had 54% of my students circle a happy face, 27 circled a medium face, and 18% circled a sad face. But overall, the students' data revealed that the majority of the class can not only demonstrate mastery on assignments regarding simplifying radical expressions, but they can also feel confident in their abilities. If I were to do anything differently in the next lesson, I would incorporate more independent practice before the Check for Understanding questions. While peer-to-peer interaction and collaboration is extremely effective and important in the classroom, I do not want my students to become dependent on their neighbor and insecure in their own abilities. Allowing students more time to work independently in Math Essentials can also increase their confidence to tackle more difficult problems independently in Algebra 1. After the teaching segment of this video, students will apply their understanding of simplifying radical expressions to successfully perform operations of radical expressions. Students will add, subtract, multiply, and divide radical expressions using the skills they practice today. As students add and subtract, they will follow the same 2 steps. The first one is to add or subtract coefficients. The second is to simplify. As students multiply and divide, they're going to follow 3 steps. The first is to multiply or divide coefficients. Second is to multiply or divide radicands. And the third is to simplify. Simplifying radical expressions is a critical step in all operations between radical expressions. And I have confidence that my students will continue to demonstrate mastery of these objectives as they continue their lessons in Math Essentials and Algebra 1. Something I want you to know about these students is they have worked so hard all year long. In August, these students entered my classroom as 8th graders who were disappointed in their Math Leap scores, hating math and thinking they could never succeed. Now, they race to see who can finish first. They are eager to answer, and they continue to demonstrate mastery on assignments and tests. I am so incredibly proud of this group of students, and I hope their excitement, enthusiasm, and intellect shows through this screen. Thank you so much for this opportunity. I hope you enjoy watching my kids thrive as much as I do. Thank you so much. Bye. Thank you for watching. watching.
YouTube channel.
And don't forget to
Don't forget like and subscribe.
don't forget to like and subscribe.